You guys are going to have a great time. You're all feeling a little under the weather. Let's just say that. Okay, I'm recording, so let's get this party started. Sum and difference. This whole unit is about taking two equations and mashing them together. Okay? That's all we're doing in this unit. It's composite functions. We're done systems now. So we're taking two equations and we're putting them together. And then we're going to graph them or we're going to solve them and it's going to be great. So today, guess how we're mashing them together? We're adding and subtracting them. It's that straightforward. So you just need to remember your brackets. Okay, some notation that might be useful to you guys is that these two things are the same thing. They mean the same thing. So f of x plus g of x could be written as f plus g of x. They mean the same thing, so don't get weirded out when you see them. And these also mean the same thing. So I think that this is the way that makes the most sense. Okay, do we think we can come back to math? Okay, awesome. I think the ones with the stars make the most sense, but oftentimes that's not the format you'll see them in. So we're going to add or subtract functions today. It's super easy. I like this unit a lot. I like this unit a lot. It is not chapter 6. It is not the depth of chapter 6. Okay, so we're going to determine the equation of h of x. So it's named the new function. The new function is h of x, and h of x is made up of the f plus g of x functions. So h of x is equal to f plus 1, and then we are going to add the g of x function. The reason why I put brackets around it is this comes into play with the subtraction. Obviously, we don't need brackets in this situation. So this would be x squared plus 2x plus 1. So you've just created the h of x function. Isn't that exciting? Okay, so now you're going to graph them. It's pretty straightforward. You got f of x, which is linear, g of x, which is a parabola, and h of x, which is a parabola. So this one's nice and easy. We're just going to go ahead and graph them. So let's pull out some information that we need to know. Maybe we'll go up to g of x. What's my vertex on g of x? 0, 0. Whoop. I'm not using an erasable pen, and this is dangerous. 0, 0. You can create a table of values for this if you're feeling uncomfortable with your grade 11 skills. So if I'm feeling uncomfortable with my grade 11 skills, when I create my table of values, I'm going to put my vertex in the middle, and I'm going to pick values on the left and right-hand side of it. So first thing you should do is always locate your vertex. So if I do -1, what's my y value? 1. If I do -2, 4, and 1, and 1, and 2, and 4. And what's beautiful about parabolas? The symmetry in them, right? So if you've done it right and you've used the same distance away from the vertex, you should get the same answers. And if you don't, then you've done something wrong. Okay, vertex on this one. Hard to see. Not straightforward. So you can either complete the square or you can use the secret formula. Minus b by 2a. So the secret formula, because you all got a tattoo of it last year, was that. And that gives you the x coordinate of the vertex. This is not on your formula sheet anywhere. And you are expected to know how to graph parabolas, well, all the time. You have that skill. Just like I expect you to know how to graph a linear one. So if you want to get a tattoo between now and the 21st. Just saying, might be a good one.
Miss Geller cake with tattoos.
I'm not paying for them. Just make sure you get somewhere you can read it. The only problem with the table of values is it might not show you your vertex. Right?
Yeah.
So you want to do a table of values if you're going to go that route. Just make sure you hit that vertex and get some points on the other side.
Okay.
That would be... so this is going to be -2 over 2 times 1. So I get -1. That's my x-coordinate of the vertex. So then to find the y-coordinate, I'm going to substitute that -1 into the equation. So I'm going to have 1 minus 2 plus 1. So my vertex of this one and then again, you can do a table of values once you know that vertex. Everybody comfortable with that? Beautiful. Okay, let's graph. Okay, so when you are putting more than one function on the same coordinate plane, what are you doing? You have to make sure they're labeled, right? Okay? And you can label them f of x, g of x, and h of x. You don't have to put the entire equation. Yep. It's a good time. All right. So do we want, let's graph the linear one first, just because it's nice. Just doing this with my grade 10s. So where's my y-intercept on this one? +1. And my slope is 2 over 1. So I'm going to go up to the right one, up to the right one. I could go down to the left one. And I get this beautiful line. And this is my f of x function. And we're going to label 2 points. Okay, I feel good about that. Now we're going to graph our g of x function. So just that basic parabola. Vertex is at 0, 0. I'm at 1, excuse me, 1, 1, and I'm at -1, 1, 2 and 4, and -2 and 4. And remember, that's not a V shape. You need to know it's a parabola, so you're going to connect it with a smooth curve. Oh dear. One of my purple pens is dying and I always pick it up. Oh hey, back off buddy, my pen was... These are very judgy. And that one is a g of x. -2 and 4. -1, +1. And I don't care what points you label, I'm just trying to keep them away from the orange points. Okay? Now we're going to graph h of x. So my vertex is shifted 1 unit to the left. And, ooh, do you guys remember the pattern? 1 away from the vertex, 1 squared up, 2 away from the vertex, 2 squared up. Do you guys remember that? Yeah. Just a quick way to graph them. So you don't have to do a table of values if you're comfortable with the quick graphing method. This is a pretty busy graph. This one isn't. Hey, doing good things over here. That's a really bad -1 and 0 there. I swear it says -1 and 0. The more likely scenario that I'm going to have is I'm going to have you do this, but only graph the h of x, just because this looks a little messy. Okay, we good?
What is this?
What? We're not solving for anything. We're not solving for points of intersection. We're not doing anything yet.
We're just doing pretty graphs.
We're just doing pretty graphs. For funsies. Okay, I see that you're all pretty excited about this. Am I good to flip the page? What are you lost with? So, if you're lost, then do a table of values. I'm going to plunk my -1 and 0 in there. So if I put 0 in here, my y is going to be 1, right? If I put 1 in there, so 1 plus 2 is 3, plus 1 is 4. So if I can do those ones, then I can do -2 is going to be at 1, and -3 is going to be at 4. So again, a table of values will never lead you astray. Like, especially when you guys get to the math fatigue part, like you've been doing math for like 2 hours on this exam, like fall back on the strategies you know will work. And you have a bunch, but sometimes in those situations we forget we have a bunch. Okay. Ooh, questions about the graph and we flip the page. State the domain and range of h of x. It's just a parabola. Welcome to grade 11. Brilliant.
Thank you.
And range? Beautiful. Okay, pretty straightforward. Grade 11, done. Determine the values of f of x, g of x, and h of x when x is equal to 4. So really what you're doing is you are evaluating each one. So all that means is I'm taking when x is equal to 4 and I'm just substituting it into the equation. That's exciting. So when x is 4, y is 9. Woo, wild, crazy. We definitely didn't graph those points. So then if I do g of x, so this one would be when x is 4, g of x is 16. The y value is 16. I'm pretty impressed that I remembered all the equations, that's all. Just showing off at this point. Recording a video. We good? Like we're on, we've got like 3 more pages to go. So skip whatever question you're stuck on. Oh, okay. All right. Okay, this is exciting. Determine the equation of the function hx, where f is minus g on this one. Okay, we good? You ready? So this is where those brackets come into play. So f comes first. And we're going to subtract g of x. So this is why I would put brackets in there. Because it's going to be that. How does everybody feel about that? I don't. Because what's the beep? I'm sorry, Nicole. I don't feel confident about that. What's the problem with that? It's not going to help us. It'll look a little nicer, but we could if we were solving for just the x-intercepts. Okay. You know what, guys? Let's do f of x and g of x. We're confident in those. We can do that. Okay. Or not. Or we're not confident in that. We did. It was chapter 2.
Okay.
It was chapter 2. It was. You were all there with me. You hated it. You told me that you hated it.
That's going to for the y values only? Is that
Okay. So let's talk about where the original graph starts. So if I'm looking at y equals root x, where does that graph start? 0. Right? And it goes like that. You guys remember this? It's got an end, a definite end value, and a forever end. Right? So where did this shift to? 1 to the right. So where is my graph? So this table of values would have been, and this was the one where we picked very unique x values. So 0, 0, 1, 1. Then where did we go? 4, oh, and then 9 and 3, right? We picked some really specific ones, okay? And what's the transformation done to this one? All we're doing is taking the x's and we are adding 1s to them. Okay, how do we feel about that? That's not bad. You guys are doing great. Good job, everybody. Ooh, and g of x is just a linear. It's that h of x one that's terrible. Okay. I feel like I want to go up by 1s again. Okay, can we do a table of value? You know what? We'll get there in a second. I'm very excited. I'm trying to jump the gun. Let's graph that radical 1 while we're here. Got that little bubble in between them. Life's good. Except I didn't go through my point, which we'll talk about later. And that is my f of x graph. And I got a 1 and 0. And I have a 2 and 1. Let me fix that one up. Okay, I don't think that helped at all. Okay, let's graph the g of x. Y-intercept? -2, and our slope is +1, so we're going to go up 1, over 1, up 1, over 1, up 1, over 1. Okay, use my handy dandy ruler. Do you know what my grade 10s are struggling with? They're not extending their graph and putting arrows on it. I don't know why. It's just who they are as people. They're not ready to, like, put arrows on things. It's weird, right? Like, they get it, they know what to do, but they're just struggling with that extension of it.
Are you teaching them set notation too?
Am I teaching them set notation?
We did have to do it in grade 10 with Lewis and friends.
You didn't have to do it in grade 10?
We did, yeah.
And I didn't with these yahoos.
Well, okay, I did technician all throughout grade 10, and as I got to grade 11, forgot it completely. Still don't know how to do it, so like, it's not everything's done.
You just said use the one that says D
Yeah. Okay, all right. So what's the problem with this equation? I don't know how to graph it. The way we dealt with it was we found the points of intersection because we were looking for a solution. So we did what Pablo suggested. We made it set it equal to 0, put 1 on either side. We isolated, we graphed the two things. We saw where they crossed. That's not what this question is asking us to do. It's saying, hey, lady, graph this. And we have no tools in our toolbox to graph it. But we do, because we're smart people. We are. Pardon? Nope. Okay, so this one was my f of x graph. And what I want you to do is I want you to create a table of values, even though we've already graphed it, for my g of x graph, but using the exact same x's. Okay, so 1, 2, 5, 10. Okay, so we got to substitute them into our g of x equation, which was x minus 2. So what is y? What's y?
-1.
Thanks. -1. 0, 3, and 8. Do you guys agree with that? Thanks, Nicole. Is it a quick question? Can I answer it quickly? Awesome. Factor.
I don't know how without the thing.
You don't know how without what thing?
X plus B.
You have to look at the constant and find the factors of that constant. What are your factors? What? You do know how to do it now? Oh, there you go. That was an easy question. I can answer that. Okay, everybody got this table down? No? Okay, so here's the deal. Because the two are subtracted, and what can we replace f of x with? Right, so what are we going to do with the y values? Subtract them. We're going to keep the x values have to be the same. This does not work if your x values aren't the same. So 1, 2, 5, and 10. And now all we're going to do is we're going to subtract the y values. So this is going to be 0 minus a -1, which should give me a +1. And then I have 1 minus 0, which should also give me a +1. And then 2 minus 3, which should give me a +1. Let's hope there's a new number coming up. And then I've got 3 minus 8, which is going to give me a -5. You're right, it is a -1. See, this is why I keep you guys around. You're so smart. So now we can graph those coordinate pairs. Tirth, are you having trouble seeing, or are you not understanding my math?
It's just there's one side is 0.
That?
Yeah.
Yeah, that's a 0. Is it not clear?
No, it's just kind of glare on the screen.
Okay. We're going to graph those points. That's all we're going to do. I need a different color. Okay, so we have 1 and 1. We have 2 and 1. We have 5 and -1. And then we have 10 and -5. Curved. Oh, sorry, guys, you can't even see my graph. Sorry. I was graphing. Do my own thing over here. Ooh, should we graph it on Desmos for funsies? Come on. Ooh, I'm getting a phone call. I'm ignoring it because you guys are more important. Mm-hmm.
What is distributed between first 2 points? Like, one and 2.
What? Sorry, say again.
Why is bit elevated between first 2 points?
That's a good question. Let us put in a value in between those and see what happens. Okay? So if I go up here and I substitute oh, I think my value goes down. I dipped it the wrong way. You're correct.
Can you do a test of that?
Square root 0.5. No, I was right. So it's that bubble between those 2 points. Okay? Okay. You don't want to graph it on Desmos just to see it?
No.
Does it look the same as ours?
How would that help?
Well, just say you believe that we did it correctly. Come on.
Well, I want to finish it before the bell.
Okay, fair. But we got a half an
I
hour.
want to sit here and get help with your
You know what, Basil? You are a kind and caring person.
Overruled your teacher.
Oh, sit down.
Just they can't see it on the screen.
Okay, the video doesn't have it. FYI, video people, Danica,
Huh?
we're graphing it on Desmos.
Oh, I'm missing out.
I know.
I mean, it's
Square root x minus 1. And then we had minus x plus 2.
Yeah. So do we have to kind of guess when there's a bubble?
You can do points in between, but if you have, sorry. So if you have 2 points in between that are the same value, then chances are there is a bubble there. Especially when you're dealing with a radical graph, you're going to have that bubble. But do you see how the bubble is not nice? It's not like a smooth curved bubble. It's like sharp and then kind of drops off. Because you have this one at 1 and you have this one at 1. Okay, so there you go. I just proved that it's perfect, which is awesome. And I'm sure you all feel like better people. Okay. Oh, the brackets I just said like here, because then the subtract has to be distributed throughout this second bracket. So that's why they're kind of useful. Okay, domain of h of x. Domain of h of x. 1 to infinity, inclusive or exclusive? Inclusive, because it includes 0. Let's do range while we're here.
-32 that.
Well, range is the next one.
Oh, okay. Okay, let's do negative infinity. And what are we looking for? Where did my Desmos go? So it's like that height there. But I'm just not sure where. Is that the highest, 1.25?
it shows you the highest.
Okay. 1.25?
Pass up before all that.
Okay. Just keep flipping back and forth between them. All right. So in those situations, it's super easy to graph things that were super hard. Okay. Determine the combined functions from the graphs. Oh, I've given you the graph. You don't. So, sketch the graph of h of x. And so this is a nice test question, exam question, where I don't give you the equations, I just give you the pretty picture, and you're required to do h of x graph. So we're going to approach it the exact same way. So I'm going to do a table of values for the f of x graph. I'm going to do a table of values for the g of x graph. And then I'm going to do a table of values for the h of x graph, which is a combination, and we're adding them this time. And so again, remember that the values that you pick have to be on both graphs, right? So if you pick x equals 1, you have to have that data point on both your f of x and g of x graphs. So shall we start with something fun like -3? How about -2? -2. So on the f of x graph, you're at -1. On the g of x graph, oh look, you're also at -1. That's nice. Okay. And then we're going to go to -1. And this will be -1. So it's really important that I do them at the same time, just to remind myself they have to be the same values. So on the f of x graph, I'm at 0. And on the g of x graph, I'm at -2. Pick 0 next. So on the f of x graph, I'm at 1. And on the g of x graph, I'm at -3. We should probably pick a positive value just for funsies. 1 and 2. And this one will be 1 and -4. So when I go to do my h of x graph, I have -2, 1, 0, 1. And so it's saying that we add the y values. You're getting closer to me. Okay, so I've got -1 plus a -1. Gives me -2. 0 plus a -2, give me -2. And then I have 1 plus -3. And then I'm going to have 2 plus -4. Holy Hannah, this has turned out to be a straight line.
Which kind of makes sense.
Well, they're both linear, right? Okay, so if we were to graph this, we're going to have -2 and -2. -1 and putting them at -1. So do we want to do a test point? Do we want to do a test point way over here at +4? So this one, f of x, would be a +5, and this one would be a -7. So plus a -7, that would be a -2. You don't have to pick numbers that are crammed next to each other. So I picked when x was 4, I picked the y values. So it looks like it gives us a nice horizontal line. Okay, you guys do the next one, but it's subtraction this time. I'll get caught up in a second. Mm-hmm.
And I have a pathway, and it's an even function because it's a 1 and 2. It's positive also. What else do I don't know what to do with this here.
You got to get the factors. I don't need x-intercepts because I'm creating an equation. I need them in factors.
How do you do that?
Well, if you know your x-intercepts at 2, -2, what's your factor of it?
x plus 2. So x plus 2, x plus 1 half, and then x minus 2. And then do I have to like times it
So,
Why is it the exact same one
0?
here?
so why? Because you're creating an equation, right?
So and then I times this, and then times this, times this.
You know what x is. If you times all these together, will you get 4?
No.
So you need to figure out what your stretch is there.
Oh, string stretch.
2 times a half. What does that give me?
1,
Times negative 2.
negative 2,
What do I need to be?
4,
So what do I need to times by negative 2 to get me to 4?
negative 2. So y equals negative 2.
And then all those factors, sure.
Is that the answer?
You just created the equation. You've created a million equations in this course. Millions.
But they never look like that.
They all look like that.
Do I have to like?
We do the stretch every time.
Do I multiply it through?
No, just leave it like that. You're done.
I don't understand that.
It was a question on the assignment.
Yes.
Okay, ladies and gentlemen, did you guys notice that the graphs were exactly the same? Okay, so do you already have the tables of f of x and g of x? So what are we doing here? We're just subtracting them, right? I added in that 4 just because I could. So we're going to subtract them. So it's going to be negative 1 minus a negative 1. And ladies and gentlemen, you do not have to put this statement here. Like, you can do it in your head. It's pretty straightforward. What? What? Oh. Okay, so graph it. Okay. Downstairs, if you go into the credenza where like the paper towels and stuff are, like in the meeting room.
Okay.
You know where you get the paper towel from in the
Yeah,
meeting room?
by your room.
Yeah,
Like
yeah.
office.
So
Okay.
don't go to the left-hand drawer, go to the right-hand drawer,
Okay.
and pull that drawer open.
Okay.
And there's paraphernalia in there.
Is
There's
there?
shirts.
Down below.
Yeah.
There are these med students and there's 6 of them.
Okay. There should be
And I
stuff in
thought
there.
Susa was going to
Yeah.
ask me now if you have anything. Oh, I'll go look.
I think there's
Bonnie's
glasses.
in a meeting with
There's-
Jolene and Jeff's doing a...
There's glasses in there.
Is there?
There's t-shirts in
Tiffany just
there.
got me pens.
There's pens. There's like little lights and
So in those things that
USBs.
you pull
Just
out,
pull out the bottom
like
drawer.
jam bars and-
Yep.
Okay, and I can steal 6?
Take whatever you need.
Each? Okay, thank you.
Standard to graduating period.
Pardon? No, they haven't arrived yet. What? I do know that the lady who was doing them for us had a death in the family, and she said they're shipping them out the end of this week. That's what I know. The 13th. Does no one read my grad emails that I send out to you?
Wait, does the lady do them in Thompson or is it like something?
Oh my goodness. We were just talking about the grad barbecue. Are you talking about hoodies?
Yeah, I remember that.
They're coming from Dauphin.
Okay. Also, grab what you. What do they have like non-meat options?
Yeah, there'll be vegetarian burgers. Okay. All right, guys. We still have we still have this recording. Please and thank you. Okay. So pretty straightforward stuff. All right, here we go. Word problems. You're going to create linear systems. This, ladies and gentlemen, is what we're doing in grade 10. Well, we're never really ever done with systems. Reach for the top. I actually got to go to this, FYI, way back in the day. Reach for the top. Mr. Odette and I went to Toronto with a group of kids. It's an academic challenge program offered to students across Canada. FYI, not anymore. Suppose the cost of t-shirts for the program includes $125 fixed cost and $7.50 per shirt. The shirts are sold for $12 each. So the total cost as a function of the number of t-shirts produced. And then we are going to create an equation regarding the revenue. Okay, you chose to do it at this time.
I'm thinking of your lesson because I have to do this.
You do. Okay. Easy peasy. How do I figure out how much making the t-shirts is going to cost me? It's a linear function. Cost. $7.50. We'll go with N because that's what it gave us. Plus whatever the starting cost is, which is $125. And that's pretty standard. The companies will design a t-shirt for you, so no matter if you order them or not, there's a fee for actually doing that design process. And then to produce them, it's $7.50. Okay, let's talk revenue. How much do I make from each t-shirt? How much do I make from each t-shirt?
$12.
That's it. If you sell no t-shirts, how much money have you collected? If we sold no t-shirts, how much revenue did I collect? 0. Revenue is just the money collected from items sold. It's not the profit, right? Profit would be revenue minus whatever your costs are, or what you get to make off that item. Okay, graph the total cost and revenue functions on the same axis. What does the point of intersection represent? Okay, first of all, let's graph them. It's your break-even point.
What's a break-even point?
That means your costs equals your revenues. So you don't lose money, but you make no money.
So no profit.
No profit.
What do you do with people who cost you like?
It's like a Jeopardy.
That's so fun.
Mm-hmm.
When did you do it?
Oh, geez, Louise. I'd have to ask. Like, I was early in my career, like maybe 2005, 2006.
I didn't know Mr. Odette had been in it.
Oh, yeah, Mr. Odette was at R.D. Parker before. He was here long before I was. And then he left us for a little bit and then came back and did Wapanoke for a bit. And now he's come back to the big school. He's been on tour. He's kind of a big deal. We had to share him with people.
I remember it was great pain, but that was an experience.
Did you have a good time?
I think everyone else did.
Not your jam?
That was an emotional roller coaster. I think everyone like enjoyed watching me suffer.
Okay, do you guys not want to graph this and we'll just graph it using Desmos?
Yes.
Are we good with that? Everybody's emotionally done. But let's go on to C for a second. Part C says, profit P is the difference between revenue minus costs. Write a function P in terms of N. So we know that P is equal to the revenue subtracting your costs, right? So the money you've collected versus the money you spent on the t-shirts. But it wants it in terms of N. So we know that cost is equal to and revenue is equal to that. So all we're going to do is substitute those values in. And this is where the brackets come in handy. Yay. No, we gotta graph it in Desmos. Chill out. All right. Off to Desmos.
Did you do your math?
No.
When you get that on?
Wednesday.
Okay. I don't
Is
know.
it hot?
No. She said she was gonna make a burger. That's basically that. For that, supposed to interview, you get them at 6. They just give you the
Okay.
like the multiple choice. A lot of them are copies that you can review and then Jeopardy, so just read that and be fine.
Did you do the actual notes?
What? I did. I read it, yeah.
Did you have to?
Okay. So, blue line is the cost, and the red line is the revenue. Oh, hang on here. I got two variables happening here. All right. So as you can see, it's not like the point of intersection isn't anywhere on this yet. So it happens somewhere in here.
Really?
That's so far away.
So what does that mean, ladies and gentlemen? If my point of intersection is here, what does that mean? It's my break-even point. So how many t-shirts do I need to sell in order to break even? 27 point something, and my break-even point will be $333. So pretty straightforward. This is a nice, easy introduction.